In this section, we'll be asked to find the equation of a line that passes through a given point and is perpendicular to a given equation. Okay, so let's see how we're going to do this. Let's say we're given the equation y equals 5x plus 3/4. And we're given the point 3 minus 1. Now, we're being asked to find the equation of the line that passes through this point and is perpendicular to this given equation. Now, don't get excited here. Let's just use what we know to write the equation of the second line. Now, our given line is in slope-intercept form, which means the slope of this line is right here. It's 5. So that's going to be m sub 1, the slope of line 1. So our second line, we know, is going to have a slope. Since it's perpendicular to this line, it's going to have the negative reciprocal of the slope. So if this slope is 5 over 1, then the slope of the line that we want to find the equation for, its slope is going to be minus 1 over 5. It's going to be the negative reciprocal. Now we simply need to find the equation of the line with a slope of minus 1 over 5 that passes through the point 3 minus 1. We know how to do this. We've done videos on this. So we can use the point slope form for the equation of this line, which should be the easiest in this situation. So we know point slope form is y minus y naught equals m, which is our slope, times x minus x naught. Okay, so we're using this form, so let's go ahead and plug in what we know. We have y minus y naught, which is a negative 1. Let's be careful with our signs. Our slope is m, so we have a minus 1 over 5 times x minus x naught, which from the given point, we just have 3. Let's go ahead and simplify this out. These two negative signs cancel, so we have y plus 1 equals minus 1 over 5 times x minus 3. Okay, so this is the equation that we're looking for. This is the equation in point slope form. Now, since our first equation is given in slope-intercept form, let's go ahead and use the same for our second line by solving for y. So we're simply going to subtract both sides by 1, so that gives us y equals, we're also going to need to distribute this. Sorry, I'm getting ahead of myself. We're going to distribute, let's go ahead and make this into 2 steps. So we're y plus 1 on the left side. Let's distribute the minus 1/5 into the parentheses. So we have minus 1 over 5 x plus, we're multiplying 2 negative signs here. 3 times 1 is 3 over 5. And now let's go ahead and subtract both sides by 1. Minus 1 on both sides. These two terms cancel, so we have y on the left side. On the right side, we have minus 1 over 5x. Let's go ahead and do another step here. We have 3 over 5 minus 1, which we can write minus 1 as minus 5 over 5, which will result in y equals minus 1 over 5x minus 2 over 5. This is the slope-intercept form equation of the line passing through the point 3 minus 1 that is also perpendicular to our given line. And we know this because we know it's perpendicular because our slopes are negative reciprocals of one another. And don't forget to check this. Take the time to check this, that when we multiply 5 and minus 1 over 5, that indeed the product of that is minus 1. And that's how we know it's perpendicular. All right, let's do a couple more. Let's say we want to find the equation of the line that passes through the point minus 4 and 1 and is perpendicular to the line 2x plus y equals 9. Okay, now here a line is given in standard form. We know that the standard form comes in the form ax plus by equals c, where our slope is minus a over b. Okay, this is what we know, so let's use what we know. We know the slope of this line is going to be minus 2 divided by 1. So a minus 2 over 1 is going to be the slope of this line, so we want to find the line that is perpendicular to this line that goes to the point minus 1 and 1. Okay, so we know that the slope of the second line is going to be the negative reciprocal of this one, so the slope of line 2, or m sub 2, is going to be a positive 1/2. And be sure to multiply these to check that they're indeed negative reciprocals and equal minus 1. Okay, so using the point slope form, with the slope and the point minus 4 and 1, we get this. We have y minus y naught, which is 1. You can see how point slope form is actually very helpful in a situation like this. And then we have our slope, which is 1/2 times x minus x naught, so x minus a negative 4. Let's put our negative sign in parentheses. We can go ahead and simplify that out. Y minus 1 equals 1/2 times x. These two negative signs cancel, so x plus 4. And there's our equation that runs through the line, or runs through the point minus 4, 1, and is perpendicular to this line right here. All right, now since our first equation was given in standard form, it's generally a good idea to have our answer, or our second equation, in standard form also. So let's go ahead and let's go ahead and distribute this out. So we have y minus 1. We're going to distribute this 1/2 into the parentheses, equals 1/2 x. 4 times 1 is 4. 4 over 2 is the same thing as 2. Okay, and let's subtract both sides. Or no, we're going for standard form, so let's go ahead and subtract both sides by 1/2 x. I'm running out of room here, so we have minus 1/2 x plus y. In the same step, let's move our minus 1 to the other side by adding 1 to both sides. So that's going to cancel, that's going to cancel. We're going to have 2 plus 1 is 3. And now all we have to do now is make sure the leading coefficient is non-negative. But if we can do this in one step, let's go ahead and multiply by minus 2 so we can have a whole number out front. That always looks a lot better. So these two negative signs will cancel, and this denominator will cancel. So we have x minus 2y equals a minus 6. We're multiplying each term by negative 2. And then that's the answer. That's our second equation of the line that is perpendicular to this line in standard form. And it also runs through this point right here. Okay, so we're just taking what we know about the different forms of linear equations, and we want to find a line that is perpendicular to one line and runs through a given point. Okay, let's do one more. Let's say we have the line y minus 2. We're given the line y minus 2 equals 8 times x plus 3. And we want to find a line that's perpendicular to this line that passes through 4 and minus 4. So our second line is going to pass through this point. So here we're given an equation that's in point slope form. So we know that from the point slope form that we wrote up here, our slope is this term right here. So our slope for line 1, m sub 1, is 8, or 8 over 1. So we know that m sub 2, or the slope of line 2, is going to be the negative reciprocal of this slope because the line's perpendicular to this line. So we have minus 1 over 8 for the slope of line 2. Now we can just use our point slope form to write out our second equation, given that it goes through this point. So we have y minus y naught, which is minus 4, equals our slope minus 1 over 8 times x minus x naught. X naught is just 4. And we can go ahead and simplify this. We can cancel the negative signs, giving us y plus 4 equals minus 1 over 8 times x minus 4. And since our first line is given in point-slope form, we can actually leave this answer in point-slope form. We don't need to convert it to anything. So this is the line that is perpendicular to this line and passes through this point. So these actually are pretty straightforward, just using what we know, and we're comparing slopes. Slopes are the most important thing when we're trying to find an equation that is perpendicular to another equation. So we'll do more of these in the next section. We'll actually be finding equations of lines that pass through a given point and are parallel to a given equation. So I'll see you soon.